Hello and welcome to day 8 of the Advent of Code 2021. My name is Jacob and I will walk you through my Kotlin solution and show you along the way how I arrived at it. This day probably was the hardest so far, at least for me. And before we get started, I'll quickly explain what this is about. If you have not read it, so I will not read the text, but if you have not read it, go ahead and read it on the page if you please. If you already know the puzzle though, you can use the chapters below to skip ahead straight to the solution. Right, let's get going. So the idea of this puzzle is that we have, as you very likely know, 7 segment displays. To display values, digits from 0 to 9, just as you know from, I don't know, a calculator or many appliances. And so how they modeled it here is that every of these segments has like a code point, and that is a char in this case. So just like A through G, and it goes like A, B, C, D is the middle one here, E, F, and G. So you can know which segment is lit up. Right, and now the goal of the puzzle is that we receive input that looks like this, with this pipe in between, such that this represents some of these digits. The thing that makes it difficult though in the case is that they do not correspond to the way that they are printed here. They are like garbled up in some way without knowing that, meaning that the characters, the code mappings, so to say, in between all of these digits within one entry, so this is one entry, we later have a bunch of them, is consistent. So like a C is the same C as here, but it's not a C in this case. It maps to, it could, but it probably maps to any of the others. So let's say a C in this input just happens to map to, I don't know, an F for this specific entry. And so what we have to do now is to figure out what digits these last 4 are, based on what we were given here. So one thing you could do, although that's pretty difficult to implement, is to try to find like the actual mappings in between, like a one-on-one mapping. So a C in this one is actually an F in the real mapping right here. I think there's a way to do this, but I'm not gonna do this, or I didn't do that because it's quite non-trivial. So instead you can apply pretty much all sorts of tricks, which made me not really enjoy this one so much, because it's just like, the code is quite ugly in my opinion, but I think there's no way around it when doing it like this. And still then it's still not so straightforward. So the goal of the first part in particular is that we only need to find how many times the digits 1, 4, 7, or 8 appear in these outputs, so to say, so everything after the pipe per entry. So we parse these entries and then iterate through them and try to see how often any of these digits appear in these last 4 outputs after the pipe character. Right, so the thing that is of course important to note here is that and that also mentioned in the text already, that the thing that makes 1, 4, 7, and 8 special. So what you can see right here is that 1 has 2, and it's the only digit has 2. 4 has 4. Likewise, 7 has 3 and 8 has 7, and all of them are unique, so there's no others that have this amount of segments. And with this knowledge, you can first of all solve all the other ones, which is not necessarily for part 1. But what this allows you to do is quite nicely at least solve the first part, which is simply finding how often do these appear. So you simply like sum everything together. So let's get going. Since I initially thought that part 2 is going to be a lot more difficult, well, it turned out to be a lot more difficult, to be fair, but like differently difficult. I modeled all of these things first, which in hindsight was a bit overkill potentially, but it makes it very type safe, which I also always appreciate. So let's jump right into part 1. So first thing we have to look at is, ignore this for now. Well, it's literally just the set of the length of the amount of segments we want. That's what you saw in the intro. So 2 segments for 1, 3 for the 7, and so on. So this is like how many segments light up, not the actual digits, not to confuse that. But what is first thing we have to look at is parse input. So we give it the input string, still with the new lines in place. So obviously first step is split by the new line character. So such that we get each of these in its own list entry. And then we map over each of them and split again by space pipe space, such that we get like the before and after here. So I called this part the inputs and this part the outputs, just to know what we're talking about. And then what I'm doing is I create this entry data class, and let's quickly look at it. It literally contains inputs and outputs, as you saw, as well as, well, or they do map to a list of patterns. What is a pattern? A pattern is a set of segments, and this is really the part that later on will help us solve this. So this just means, yeah, one of these things is one pattern. So you see they have these segments corresponding to the ones you see in the diagram on the page, or in this case actually not, right? Because they're mixed up. So let's check out what a segment is. A segment literally is in this case just an enum that maps all the digits. This is of course not necessary. You might as well here say set of char, right? Because these are just chars. I only did this, as you notice later, because it's a bit more type safe, and well, it's not like the input will contain chars that are not out of this set, out of this enum, so to say, but it allows, yeah, it just makes the code a bit nicer in my opinion, but this is not necessary on paper. You see right here it has one like helper constructor function that is static. We look at this in a second. The last thing, while we're anyways down here, let's look quickly at our digit enum. This is also pretty much the same as this one. It literally just maps all the allowed digits. In this case, it has a bit of a better use case than just being type safe, because it also allows for nice matching with the when statement, for instance, because this is yeah, like a sealed interface, so to say. So these are the only values that this can take. And instead of doing it with the integers, as you later see, I'll explain it a bit in a bit when we see that, which of course would allow any integer. So now we just constrain ourselves a bit and make it again more type safe. Again, not required. You might as well have the integers of these segments, but I figured it makes the code nicer. Right, before we jumped into this rabbit hole of the extra classes I modeled in here, we were here. So we construct the entries simply by deconstructing this. So in case you don't know how this works, in Kotlin you can give, with the parentheses and a val, you can essentially unpack whatever's on this side if it supports this, which is collections typically, such that this is the first entry in this collection, this is the second, and you can chain arbitrary more to this. And in this case, we know that we will only have 2. Well, at least if the input is correct, but we expect that we will only have 2, right? Because we split here with the pipe. So before and after, such that we can just immediately unpack that into variables called inputs and outputs, which is a bit nicer than saying get at index 0 and so on. So last step in parsing, and then we're done with that finally, is to actually, well, get all of these patterns, digit segments and stuff. So parse signals is for that. So you give it, well, a list of signals. So this would be this marked entire string in this case. So obviously first thing we do is we split by space characters such that we get each pattern individually. Important here is that we have to filter out everything that is not blank, because if you do that, you might get the beginning and end. I think in this case, actually, it's fine because we already split it away here, but just to be on the safe side. And then the final step is we map this into a pattern. So how this would work is we split by, well, empty string. So we get like each of these individually, right? Because now we're already like mapping over that. So one signal would be one of these. And now it is important that we say this step right here, because if you split by just empty string, you will get like an empty string at the beginning and at the end, because there's technically like an empty string before and after this signal. So we have to filter these out.
Then I map each of them to a char array. There's probably a nicer way to do this, but I think this is the most straightforward one. So now we have like each of them is one character, right? But they're still a string, and I want them to be chars. So I just say make this D into a char array, which means literally an array of size 1 with just a D. So I can just take the first one. So I have a list of chars. And then finally, you see this static function right here. We convert this into a pattern. So we give it a collection of chars because we mapped over all of them. And then we literally just say from the, like, try to find what segment that corresponds with. So we say segment from symbol. So similarly, this has a static helper method. And this literally just looks up in its values which one corresponds to the segment. So that means that in the end, I will run this in a second so you see it, because it's quite a lot of code. You will have a pattern that contains these segments, of course, with not matching mappings. And then in the end, you have inputs and outputs as a list of these right here. One thing that's quite interesting here to note before running it is I used the let extension function right here, in case you're not familiar with that. So you can essentially run something in here, and that is returned from the entire function. So compared to like an also, for instance, or some of the other extension functions. By the way, I have a full video on that if you're not familiar with all of them in its details. If you use let, whatever you do in here is like returned by this entire function, so you can return it from here. This is quite nice for like when you have multiple of chain operations already, because otherwise, of course, what I would have to do is do this, which in my opinion just looks a bit, yeah, I don't know, looks a bit ugly. Of course, you can format it and stuff, but yeah, arguably this looks worse in my opinion than the other one. But this is a bit, yeah, up to the author, because I can also see that people don't like lists, but it's a pretty nice thing to have. Right, let's now quickly run this, because otherwise I think this is very confusing what's going on here. If you do understand it, feel free to skip ahead, of course. But let's take a quick peek. So I just ran parse input here in the debugger to see what we would receive. And it looks like this. So we have our entries, and let's just look at, I don't know, the first one. So we have inputs and outputs, right? This is before and after the pipe, you saw that. And then in there, we just have simply now a typesafe way of representing these segments like this. So literally, this is just the input in a completely typesafe way. So we completely eliminated primitive types such as chars and integers out of this, and it just has like sealed typesafe stuff instead. So you would see this is DCGA, which obviously if we check our input is the first one, DCGA, and so that's literally all we're doing. And this will make it a bit easier, in my opinion, for the steps to actually find the mappings. If you have it like this, plus I just prefer it to be typesafe instead of being like a nested list of int that is in a list of something else and so on. That becomes very unreadable quickly, in my opinion. This at least is very clear what's going on. It's of course a very personal taste, but I think, yeah, I personally prefer it. Now for puzzle 1, there's 2 ways you can solve this. Sorry, for part 1. Like a straightforward one and a bit more convoluted one. Let's do the straightforward one first, because this is very valid to do it like that. So what you can literally do, since if we check again, the idea is just counting how often 1, 4, 7, and 8 appear only in the outputs, with the knowledge that these have like unique length, we can now use what you already saw here earlier. So literally all we can do is we can sum over all of our entries and take the outputs of that and then count how often in the output there are segments that have a length or a count of any of these. So meaning that we know then there are 1, 4s, 7s, and 8s because they have these and any of these lengths. So we just say count how many of the outputs have this length, and then this of course returns an integer, and in the end we just sum together, which is precisely what this asks for. How many do they appear like summed together? And then we have our answer already. So there's another way to do this, and let me revert this right here, because then that will allow us to also solve part 2. Before that though, let's quickly check part 2 So the idea of part 2 is now it becomes difficult. So this was easily solvable, right, with this trick, so to say. Of course, another thing you could have done here is literally parse, hey, what are these numbers? And you just realize, oh, it's a 1 in this case, for instance, because it has two segments. So I know it's a 1, so I count it once, and then in the end I arrive at my number. That is the other way you could have done it, of course, and that is what you have to do for part 2. So let me quickly explain it. Again, skip ahead if you already are aware of this. The idea of part 2 now is that we have to actually just parse or like find out what these digits are right here. So not just anymore these ones that are unique, so you can very easily do it with this trick, but you actually have to look at the input first, realize what the characters mean, and then try to find out what is this here. So what I did in this case, because that is straightforward, more or less at least, is that since this is a set of characters, right, per set, you at least know that if you have the same pattern but in a different order in the input right here, you know that it must be the same digit down here, right? So for instance, if we look at if we look at this one, for instance, right here, we know this has to be the same digit as this one, because it has a C, it has a D, it has an F. It is a different position, but these are just sets. There's no ordering to it. Technically, that's precisely why I modeled it as a set and not a list. Otherwise, of course, it wouldn't be equal. There's a B as well, and there's an E. So we know this, whatever the digit actually is, these ones are the same. This is the basis of how I solved it. Keeping that in mind. And then what we essentially, what I essentially did then is, in the inputs here, I try to find out all the numbers and just create a mapping of that. We'll look at it in a second, such that then in the second part right here, I can just look up in my map, hey, what is CDFEB as a set, right? So order doesn't matter anymore. And then I look up in my map that I created from the inputs here, what is that? Technically this is not even fully required, because you don't have to parse all of them, because not everything appears in here even. So you could make this first step a bit shorter. In my opinion, though, it's easier to understand, and also, well, why not? It's not like it takes very long. So I just resolve all of them and then just look up in the second step here. There's quicker ways to do it, but yeah, I think they also, this is fine. So the final thing then we need to do is well, actually, let's look at this later, because it's a bit, it takes away from the idea itself. Let's instead check out the code. So part 2 starts obviously again with parsing the input. You saw that now, what that happens to be. We again have to sum over everything, but we have to sum something else. So let's look at this last line at the very end. Instead, let's focus on this, which is the actual heavy lifting, let's say. So what I'm trying to say, what I'm trying to calculate here is precisely what I showed you on the page. So we have a map from pattern to digit. Pattern, if you remember, again, is one of these patterns, and because its equality is based on a set. Reason being that this is a data class, so the default equals and hashcode method use all of the fields. We only have a single field, right? So it will just use the equals and hashcodes method in essence of the field. And then we see, hey, this field is a set. And the hashcode and equals method of a set, well, that compares if one set contains all the elements of another, of the one you compare it to. Obviously discarding order, that's why it's a set. Such that if we have this map right here, we can give it like any pattern that contains these segments in any order, and it will always map to the same hashcode, meaning that we can later look up with any other pattern that is the same, and we'll receive that. So in this case here, if this is our pattern, let's say, and we say, hey, is there a digit that this pattern is known for, we will map it with this one, or it will match this one, because of this equality reasoning that the data class has. So this is very important to keep in mind. Otherwise, this wouldn't work. If we here have a default class, let's say, and forgot either to add equals and hash code, or they're implemented somehow differently, then this would fall apart. So this is literally important here. Right. If this doesn't make sense, drop me a comment below. I'll make sure to elaborate a bit more. Right. So this is the goal that we want, because then in the second step, you see it here already maybe, but we can just literally look up for all of the outputs. We can just say, hey, find me my digit that matches this pattern, and then do something with that. Again, the last part we look at in a second. The actual interesting thing is obviously process entry, because that's where all the magic happens. I think this is pretty straightforward. So process entry. This is not very nice looking code. I'm not super happy with it either, but I think, yeah, it's the best it gets. So what happens here is the following, or the way that I thought this can be solved, at least more or less nicely. We obviously start with our empty map of mappings. Note here though that the map is the other way around. So the keys are digits and the values are the patterns, such that we can later on try to find, and that's the whole goal of this algorithm, so to say, in here, we can try to find, based on knowing which patterns for digits are already known, try to find how they compare to each other. And I will go through the rules with you in a second. So for this whole thing here to work, the first thing we need to do, and this is what I think makes this a bit ugly, but well, that's how it is. We need to try to find all the ones that are unique, just as in the first thing, because that will allow us later on to resolve all the others very nicely. I'll show in a second how. So what I do in this case is a nice when statement. So I just essentially do the same that you saw previously here before I reverted it. So I just check, hey, how many segments do we have? And then we know if it's 2, it must be a 1. And this is now where the first part where these enums come in handy, because it's like a nice direct mapping to what they actually are. So if it's 2, we know it's a 1. If it's 3, we know it's a 7, and so on. Else, and it's really nice about Kotlin in my opinion, this because it evaluates to like an expression, and we can just skip this iteration in here because we cannot know yet at least which this is. So what we do here, we only try to resolve the ones we can know with 100% certainty. And then obviously what we can do with this is we can say in our mappings, we know now that whatever pattern this digit has, we save it in our map. Let's quickly run it, because I think this is a bit potentially confusing how this would look like. So we just want to try to find out for this entry. Also keep that in mind, it's only for a single entry, meaning for one of these lines only. So per line this changes. So it's not like if you resolve the first one you can like resolve all of them. You have to do over the same resolving per entry. So what we would have right here is, let's run this a couple of times. Right, so the mappings now would look like this. We know that a 4 in this entry contains the segment D, C, G, and A, just because of this mapping right here. We know that that's a given fact. So yeah, same we can do with 8, and then we do this with all of the others as well, such that once we reach this point here, we have all of our mappings, and we know what these are. And now comes the part that is a bit iffy, but yeah, I think it's not too hard to understand. It's just a bit annoying. So what we now need to do, or what I did, is based on the information that we now have here, we can more or less easily resolve based on that what all of the other digits are. So I again iterate over all of the digits, this time filtering out all the ones that are already values in my, I iterate over all the patterns, of course, filtering out right here all of the ones that are already known, because obviously this map should only contain like one digit to one pattern, so one-to-one mapping. So the ones that we matched here already, we obviously don't need to do again. So we just skip them, meaning that everything that is iterated over here is anything but a 4, 8, 7, and 1. Just trying to find out all of the others. And then what I'm trying to do is I wrote a function right here that tries to, for each digit there is, honestly here we could have also again filtered out all of these because yeah, that cannot be it anymore. We try to find the first, so this is also short circuiting, that's nice. That is that digit. And then how that is implemented is this thing here. So on the input pattern, I added a method that is called isIt, and you give it a digit. So these digit values right here would be yeah, this should be digit.values. It's just because I imported it, so this looks a bit weird. For each digit we know about, so each of these enums here, we say, hey, is this input pattern that digit? And of course now we have to look at how this works, and passing in we need to the mappings of this entry. Obviously per entry this changes, as I said, so this function needs to know about, for this entry, what are the like garbled up mappings. And then the final step, once we know the digit, which we can resolve yeah, with certainty here, we literally just again add it to our map right here, and in the end we just return the map. So last thing almost to check is this part, so let's do that. Doesn't look very nice, but yeah, I think honestly it's the only way to do this. So what I do right here is, for each digit there's certain properties that make it such that if you know these ones, so the patterns for the ones that you can resolve based on the amount of segments, you can resolve any of the others with some tricks. So let's look at a few examples of these, and the others you can go over yourself. So yeah, I don't know, let's say a 3 for instance. So a 3 you can 100% detect by doing the following. We first check is its count, and count in here is just how many segments does it have, is equal to 5. So there's only 3 digits that have 5. So let's go to the top here, which is 2, 3, and 5. That's the only one that have 5 segments, right? And all the others have something else. But of course we don't know yet, is it 2, 3, or 5? Could be any of those. So first thing to check to know it's a 3 is it has 5 segments, but of course that still leaves us with the options, it's a 2 or a 5. So now what we can just do, and this is how this whole when expression here works, we check in this case, and this differs of course, we intersect it. So we take like which of the mappings of our 1 digit is also in our 3 digit, and then we see that this is exactly 2. So what would this mean? So we have our 1 mapping right here. So this is a D and an A. It doesn't even matter too much what these are. The important thing to keep in mind here is that if you would intersect, so you would get everything that's in both out of 3 and 1, it would be here C and F, right? So C is in 3 and in 1, and F as well. Everything else not. And that is what it completely distincts it from 2 and 5, which also are still in the race for being length 5. Because the intersection between 1 and 2 is C, because here 2 doesn't have an F, right? And 5, on the other hand, doesn't have a C. So we know that if we get like the segments that are in both, and they also are 2 of them, it has to be 3 at this point. So the 3 we can completely detect by has 5 segments, and if we intersect it with 1, it has 2 matches, so to say. If it has 1 match, it could be either a 2 or a 5, so we would have to do some extra step. But if it has 2, we know for certainty it's a 3. And this is how all these others work. Let's walk through one extra one, and then the other ones I would suggest, since this code is on GitHub, you can look over there, since this is not very interesting, I think, if I go over all 10 digits with you. So we literally just concatenate here. The nice thing, at least, about this is that it's, of course, also short circuiting. So it tries them one by one, but if like this already is false, then yeah, it won't even start intersecting here. Same here at the beginning with the first. This is also short circuiting, such as, so what this does is like it tries to find the first that is true in this expression. So we start with 0 and say, is this pattern a 0? and then continue. Let's say it is a 3, so we do, is it a 0? No. Is it a 2? 1? No. Is it a 2? No. Is it a 3? Yes. So it wouldn't even try to iterate over the rest anymore. So this is at least more or less nice, as nice as this solution can get. And this again is of course here short-circuiting here as well, since if this doesn't work, then it won't try the stuff afterwards. So you see I left in here the 1 and the 4 and so on that can be matched directly. Not really necessary, right? Because we already have them in the mappings map right here, so they would all be contained in here. Otherwise, actually, this doesn't work. But I figured, first of all, such that the when statement is complete, and this is precisely where it comes in handy now that these are enum values and not integers, right? Because if these would be integers, it would say here it doesn't compile, because the when statement is like, hey, there's more integers than 0 to 9. What about all the others? So of course you can do else and throw an exception. It's not super horrible, but I figure this is a bit nicer and yeah, more type safe, as I already alluded to. This is also the main thing that does annoy me a bit about it. Of course, this could be done also type safe, but the fact that these mappings, you see here, this is already a red flag, obviously, that I used the nullability ignoring operator. So I just say, hey, give me the mapping for 1, and if it's not in the map, then throw an exception. So we cannot statically check that anymore, of course. Like this map just has to contain 1, 7, and 4 in these cases, because these are the ones we use somewhere. If it doesn't, this explodes. So if I would write this in actual application, this would obviously not be like that, but it would check that these are there beforehand, or you would do it maybe not as a map, but as something that type safely has like fields of 1, what is the 1 mapping, what is the 4 mapping, and so on, which is also a bit ugly, but at least then you can get that eliminated. So that's my main improvement point, I guess. But it's fine enough, I guess, for this kind of puzzle, at least. Just a note at the side. So let's look at one other one, and then let's see how to round it up. So for instance, let's maybe take, let's take the 5, since you already looked at that. So the way to find a 5 is, again, of course, to see, does it have 5 segments, which still leaves in arrays a 3 and a 2, as we saw previously. So now what we can say is it not a 3? And this is where you also see here in IntelliJ, it gets recursive, actually. So this calls itself with the same mappings, this time though asking, is it a 3? And then we negate this. So we check, does it have 5 segments? Is it not a 3? And then obviously what is still in the arrays, well, 3 is obviously discarded by this, is a 2. So it could still be a 2. So this last thing, and you see also 5 is the only one, at least I didn't find a nicer way to do it without checking 3 things. All the others you can do with 1 or 2. Oh no, here's more that you need 3, never mind. The last thing to detect it very completely safely is that you try to see how many intersecting segments it has with 4. In this case, it needs to be 3. So let's quickly check that out. So if we intersect 2, which was still in the race, with 4, we see that it maps in C and D. B and F are only in one or the other, so it has 2 matches. And if you intersect the 4 segments with the 5, you see that it has B, D, and F. So 1 more. Meaning that in here, if we say, hey, these are 3, at this point, this doesn't tell us necessarily it's a 5, but with these others in front, we know it's a 5. So at this point, we can safely discard that it's a 2, and then we return true here. And that's literally how this works. So at the very end, all we then do is, once we have this map right here that I explained now. So for each of the output values, so the ones after the pipe right here, we have to like get which digit this is, which digit this maps to, and then just like concatenate them together into a new integer. So let's say this would be, I don't know, that's not correct, but let's say it's 1, 2, 3, 4. Definitely not correct, but whatever. We would concatenate together to 1234. So you just essentially remove the spaces. And then when you have that, we simply sum that together. So this can be done quite nicely in Kotlin by saying, well, first of all, as you saw already, we get out of our mappings the digit each time, and then the digit has a value field, which is then the literal integer. So that's in here. So we just get the literal integer of that. We join it together to a string with no separator. And then we just convert that to an integer, so that it would be, like I said, 1, 2, 3, 4. And then finally we return this into our sum of, such that each of the values for each entry are finally summed together here, and we receive our output. So let's quickly look at how the mappings look in the very final step when they're full for one of the entries. And then we're done right here. So nope, this breakpoint can go. Right, here we are. So this is how it would look like for the first entry, for instance. You can see it right here. So we know for a fact now that, I don't know, 0 is GB and so on. So if it happens to be in here, which I think is, no, that's not it. Well, we just look it up for each of these. Hey, which is that based on this right here. Yeah, that is day 8 of the Advent of Code. If you do have any questions, since in my opinion this was one of the harder ones, don't hesitate to drop a comment. I'm very happy to respond to them. Also make sure to join the leaderboard, which you can find in the description if you also are participating. And apart from that, I see you tomorrow for day 9. Tschüss!